Hello everyone, I welcome you to this math lecture series. Today we are going to discuss about inverse of a matrix. This is a video by See Through Max. So what are the things we are going to see in this one? Conditions for finding inverse of a matrix. This itself says that the inverse does not exist for all matrices. There are some type of matrices only for those things inverse exist. The second one, we are going to solve problems for finding inverse of a matrix. So mainly we want to look for two conditions. The first condition, we want to check whether the matrix is a square matrix or not. If the matrix is square matrix, then we can able to find inverse. If the matrix itself is not a square matrix, then inverse we cannot able to find. So square matrix means the number of rows and the number of columns of a matrix are same, then it is a square matrix. The second condition says that if the matrix A is non-singular, then inverse exists. That means the determinant of A is not equal to 0. If determinant of A is equal to 0, then we cannot find inverse of a matrix. And the rule to find A inverse is equal to 1 by determinant of A multiplied by adjoint of A. One more point we want to note, if the matrix along with its inverse is multiplied, then it is equal to identity matrix. So whether it is pre-multiply or post-multiply, both are same in this case. Now we'll solve a problem to find inverse of a matrix. This is a 2 cross 2 matrix, so it is a square matrix. So how to find inverse for this matrix? The first step is to find the determinant. So it is easy for us to find determinant for a 2 cross 2 matrix. Take the diagonal elements, so 2 and 5. So multiply 2 multiplication 5. Then multiply the other two elements, so minus 4 multiplication 3. So put subtraction in between. So we'll get the answer, it is 22. And we will make sure that it is not equal to 0. That means it is non-singular matrix. So inverse exists. Now write the rule for inverse. A inverse is equal to 1 by determinant of A into adjoint of A. Already we have calculated determinant of A. Now we want to find adjoint of A. Even though there is a procedure to find adjoint of A, but for 2 cross 2 matrix, directly we can able to write. First, here you can see the matrix, and we want to remember this plus or minus matrix. Once we are calculating this one, then we want to multiply this plus or minus. Means plus 1, minus means minus 1. Just change of sign. Only at few places. Okay, so adjoint of A is nothing but how we want to do, go to the matrix A, take the principal diagonal elements 2 and 5. Just reverse this, that means 2, 5, you write it as 5, 2. So here it becomes 5, 2. Now the other side, it is minus 4 and 3. Here don't change the place values, but only multiply by minus. Those two places are minus, so just multiply by minus. So minus 4 becomes plus 4 and 3 becomes minus 3. So this is adjoint of A. Therefore, A inverse is equal to 1 divided by 22 multiplication 5, 4, minus 3, 2. 5, 4, minus 3, 2. This is the inverse for the given matrix A. Now we go to the next problem. Find the inverse of the matrix if it exists. And A is given, it is a 3 cross 3 matrix. Definitely this is a square matrix. The first condition for inverse satisfied. So the second condition, find the determinant of A. So it is easy for us to find the determinant of A. What is that one? So here I wish to expand using first row. You are free to expand using any row or any column. Anyway, here in this first row, the first element is 2. So 2 multiplied by its minor. So here its minor is 4, 1, 7, 2. So multiply by this one. That means 4 multiplication 2 minus 1 multiplication 7. So directly I'll write it as 8 minus 7. 2 multiplication 8 minus 7. Then minus, here this 3 comes again, multiplied by, now remove this row and this column. We get the minor 3, 1, 3, 2. So now you find the determinant of this one. 3 multiplication 2 is 6. See here 6. Then 1 multiplication 3 is 3. So 3. So you want to subtract. Next one is plus 1, this 1. Now remove this row and remove this column, and the remaining is 3, 4, 3, 7. Find the minor for this one. That means 3 multiplication 7 is 21. See here 21. Then 4 multiplication 3 is 12. So 12. So 21 minus 12. So now I simplify this one and we get the answer 2. So 2 is not equal to 0. So A inverse exists. Since the determinant of A is equal to 2, which is not equal to 0, the inverse exists. Now write the rule A inverse is equal to 1 by determinant of A multiplication adjoint of A. Again, I take the matrix A, easy for us to do calculation. And remember the plus or minus matrix. So you want to start with the value plus, that means plus 1. Minus means minus 1. When we calculate the value after then, that means when we calculate the cofactor values, we want to multiply by minus to few elements. So here itself, it's a pattern. You can see the pattern, plus minus. It's alternating plus minus. Since the first row, it starts with plus, the second row starts with minus. This is easy for us to remember. Now, so how to find adjoint of A? Again, completely we are finding minor for each of these elements. So take the first element, it is 2. Remove first row and first column. We'll get another minor 4, 1, 7, 2. Find the determinant of that one. So 4 into 2 is 8 minus 1 into 7. Get 7. The next one is for this number 3. We get 3 into 2, 6. 6 minus 3. 6 minus 3. But this minus is nothing but comes from this minus. The same way, find the minor for 1. What it is? 3 multiplication 7, 21 minus 4 into 3, 12. So 21 minus 12. Now go to the next element. So we can easily cross check at any place also. And here I am writing in order. That means this is second row, first column element. So to find this value, directly go here, second row, first column element. It is 3. Now remove second row, first column. I will get 3, 1, 7, 2. Now find the determinant for this one. 3 multiplication 2 is 6 minus 7. 6 minus 7. And this is multiplied by minus 1. Here it is. To write this adjoint of A, I will see the matrix as well as this plus or minus matrix. Now go to the next one, 4. For this one, remove the second row, remove the second column. So 2 multiplication to 4, 4 minus 3. 4 minus 3. The next one, minus of 14 minus 9. How it is 14 minus 9? Second row, third column. Second row, third column, I leave it. Second row, third column, I leave it. So 2 multiplication 7 is 14. 3 multiplication 3 is 9. The same way we fill all these elements. We will get adjoint of A. So therefore, A inverse is equal to 1 divided by 2. The determinant value of A is 2. So it is 1 by 2. Multiplication. So you simplify this matrix. It is 1 minus 3, 9, 1, 1 minus 5, minus 1, 1 minus 1. Whole transpose. So here I have written by changing the rows to columns and columns to rows. That means transpose. And this is the inverse for A. I hope so you have enjoyed this video. This is a video by See Through Maths. Subscribe this one, click the bell button and share this one with your friends. Thanks for watching. See you in another video.